Welcome to the session on constant acceleration formulae part 2. The objectives for this session are to derive the formulae for constant acceleration and use them in order to solve problems. We're going to begin this session by reminding ourselves of some standard notation which we introduced in the last session. So the following letters are used for an object moving in a straight line with constant acceleration. S represents displacement, u initial velocity, v final velocity, a acceleration, and t the time taken. The formulae which we've derived were v equals u plus at and s equals u plus v all over 2 times t. We're going to label these 1 and 2 respectively as shown. An illustration of this notation is as follows. So we begin, say, with a particle moving in a straight line with constant acceleration. At time 0, the initial velocity u, the constant acceleration is a, and the final velocity after t seconds is v. The displacement is s. We're now going to derive some formulae, but before we begin, let's observe some things from the current formula that we have. Notice in the first formula, v equals u plus at, there is no displacement s in this formula. In the second formula, there is no acceleration a. So now we're going to derive a formula which eliminates t from the formula for constant acceleration. So essentially we're going to use the two existing formulas to derive 3 or more. Let's rearrange one to give t equals v minus u all over a. Then substitute this in equation 2, as shown here. T, of course, is here. And when we multiply out and rearrange, we obtain 2as equals v squared minus u squared. This is more commonly written as v squared equals u squared plus 2as. So this is our third formula. So let's summarize again. There's no displacement s in the first formula. There is no acceleration a in the second formula. And there is no time t in the third formula. We're now going to derive a formula which eliminates v from the formula for constant acceleration. So let's substitute equation 1 in equation 2 to give s equals u plus at all over 2 times t. Clearly we've simply substituted u plus at in place of v. If we multiply out and rearrange and tidy up, we obtain s equals ut plus a half at squared. And this is our next formula. So again, let's summarize. The first formula has no s. The second formula has no a. The third formula has no time t. And the fourth formula has no final velocity v. So now we're going to derive a formula which eliminates u from the formula for constant acceleration. So let's rearrange equation 1 to give u equals v minus at, as shown. We now substitute this in equation 4 to give S equals V minus AT, which has replaced U, times T plus a half AT squared. And here's where we've replaced U. Rearranging gives us S equals Vt minus a half AT squared. And this is our final formula. Now let's apply these formulae to an example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We have that an object moves from A to B in a straight line with constant acceleration 7 meters per second squared in the direction AB and velocity 4 meters per second at A. If the velocity of the object at B is 25 meters per second, find the distance between A and B. So let's solve this. We begin by sketching. We have point A and point B. The object moves from A to B in a straight line with acceleration 7 meters per second squared and velocity or initial velocity at A 4 meters per second. And final velocity, or the velocity at B, is 25 meters per second. We're required to find the distance between A and B, which is of course denoted by S. So we have U, we have V, we have A, and we're required to find S. The formula highlighted, in other words the third formula, V squared equals U squared plus 2AS, has all of these letters in it, and T is not involved at all in this scenario, so we only use this formula. Let's plug in the values. V equals 25 goes here, U equals 4 goes here, 2 is part of the formula, acceleration A equals 7, and S is what we're looking for. So we can tidy up as shown and solve for S to give S equals 43.5 meters per second. And now for example 2. Pause the video and have a go. Press play when you're ready to view the solutions. So let's sketch this first. We have a penguin sliding across a frozen lake in a straight line. His initial speed is 6 meters per second. Friction causes him to decelerate at a constant rate of 1.5 meters per second squared. We are required to find in part A the distance the penguin has moved before coming to rest, and in part B the time when he is at half the total distance. So let's sketch this. We have the penguin decelerating at 1.5 meters per second squared, therefore A equals minus 1.5 meters per second squared. His initial speed is 6 meters per second, so U equals 6 meters per second. And he comes to rest in part A, so V equals 0, and we're required to find the distance between when he started and when he came to rest. And that is of course represented by S. So again, we're going to use the formula V squared equals U squared plus 2AS because we're not required to find T at all. So let's plug in the values as before. We have v equals 0 and u equals 6. 2 is part of the formula. A equals minus 1.5. And S is what we're required to find. So tidying up gives us this expression, and solving for S gives us that S equals 12 meters. And now for part B. We are required to find the time when he is at half the total distance. So let's sketch this again. We have initial velocity u equals 6 meters per second. Acceleration minus 1.5 meters per second squared. Velocity, or the final velocity here, v equals 0, but we're not considering this part of the journey. This is 12 meters, this distance. We found that from part A. So half this distance, and we're going to find this time when he's at half the distance is time t. And of course we have, for this journey, a distance of 6 meters, so S equals 6 meters. So what do we have? We have S, the displacement, we have u, the initial velocity, we have a, the acceleration, and we are required to find t. So we need a formula which does not include v. And S equals ut plus a half at squared is the only formula which doesn't include v, but includes all the other letters. So let's plug in the values. S equals 6, u equals 6, t we're required to find, a half which is part of the formula, a equals minus 1.5, and here's our formula. So we multiply out by 4 in order to get a nicer formula, or a nicer presentation of the formula, and tidy up. And solve the quadratic. To give t equals 6.83 or 1.17 seconds. This brings us to the end of this session. If you have understood its contents, you should be able to derive the formulae for constant acceleration and use them in order to solve problems. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.